One Mississippi, 2 Mississippi. Alrighty, I think we are now live. I'm just gonna put the chat window up on screen somewhere where I can find it. And I think, yeah. So I have a turtle walking around on my floor, so I may get sidetracked as I go to get my turtle, pick him up once in a while. Pick her up, she's a female turtle. But anyway, so we're in the shop today, and, got to move that up. And, well, we're going to try some new nozzles. Basically, I ordered a set of different nozzles for my 3D printer. Periodically, I have to replace, the ones I'm using, especially if you are working with a brass nozzle. Brass nozzles tend to wear out, but they also tend to be, I think, they conduct heat better than the alternative, which is typically steel or hardened steel. It's just that if using a carbon fiber, in fact, I should really put this in a bag of silica gel to keep it from absorbing moisture. You'll notice this one has a rough texture to it, and that is because this filament contains pieces of carbon fiber. It adds more structural, integrity, better rigidity or whatnot, to the print. That particular one recommends using a 0.6 millimeter nozzle as opposed to what I typically use, a 0.4 millimeter. 0.4 millimeter is a decent balance between, resolution and speed. What do I mean by resolution? Well, here's an example of the flagship Hyperion. This is Yang Wen Lee's flagship from Legend of the Galactic Heroes. And this is the first time I paid money for a model. I paid like $35 for this. And if the camera would kindly focus so that I don't have to manually do it, I can show you the level of detail. And so, on any 3D printer, you're doing it one layer at a time. So clearly I printed this standing up vertically like this. And overall, I'd say the resolution was pretty decent. We have the most of the details, if that matter. The only thing is like the antennas or the sensor and comm array. Yeah, that looks sketchy. But no big deal. I can use an X-Acto knife on that. I can use a hot knife on it. And ultimately, I'm going to be shoving metal wire or brass rods into the antennas. Like, one cool thing was the guy who designed his model said, he didn't include the antennas because they don't print correctly anyway. That, you can't really print a narrow antenna in PLA or plastic-like material. But you can, easily heat up a metal wire or a metal rod and stab it into your model. And so the guy included links to, order brass rods on Amazon. But I could also use the metal wire that you use for cleaning the 3D printer nozzle. So a lot of these nozzles will come with this wire here, or, metal pin or needle. And what I find funny is when you see these videos where people are telling you how to clear a clogged nozzle, and you'll see someone go up to a printer that isn't on or that's cool and use a set of pliers to pull the clog out. And I don't know why people do that. It's like, why would you make it more difficult? When I have a clogged nozzle, my main go-to is to heat it up, to tell the software to just cook that nozzle. So for example, here we go again. I gotta hit the button again. I would, warm it up even higher than normal printing temperature. And, anything that's clogged will either melt away or ooze out. If there's still a clog, you can shove a needle into it from the top or the bottom. So if you gotta remove the tubing and shove the needle in from the top, and that will typically clear your clog. And then from there, if you want to use a different nozzle, you can remove the nozzle. But I would not remove a clogged nozzle until I declogged it by using the heat on the printer. And if I really had to, sure, I could do it on the stove pilot. I could do it on, a boiling pot of water, in a boiling pot of water. But, you should, I think, I would look for the path of least resistance in that regard. And that's what it looks like to me. Beyond that, to change a nozzle, to swap out a nozzle, you do, need to heat it up, in my opinion. Like, if I put on a nozzle while it's cold, it's going to expand, the aluminum block will expand, and the nozzle will become loose once it heats up. Conversely, if I, heat it up, I tighten the nozzle a bit, it'll usually be too tight to remove when it cools down. So usually to remove the old nozzle, I have to heat it up anyway. And so that's why you know, we did this. We have this warming up right now. And so from here, we're going to go ahead and proceed with that process. Now, I should briefly talk about the nozzles I've got. So, you know, normally I use a 0.4 millimeter nozzle. And what that means is when using the Slicer software, which is really just the program that takes your downloaded file and prepares it for printing, gives you a preview. Now, I already printed the front of the ship in a larger size, but I want to see this printed today in its entirety. So I shrunk the model and I decided to print both sides at the same time. And then when I go to bed tonight or after this is done printing, I'll tell it to print the rest of the ship, which may be a bad idea. I'm thinking about it now because I'm realizing that I already printed this on a 0.4 millimeter nozzle. But you know what? It's fine. I can always print out both ends because I really am looking forward to seeing the results on a higher quality, a finer nozzle. So we're switching to a 0.2 millimeter nozzle. We have brass nozzles, like I mentioned already, which wear out more rapidly, but are very cheap and easy to replace. And they came in sizes ranging from like 0.2 to 1 millimeter. So 0.2, 0.3, 0.4, 0.5. I was surprised they had a 0.3 and a 0.5. 0.6 and 0.8 and 1, but typically I think standard nozzle sizes are 0.4, 0.2, 0.4, 0.8 are pretty standard. 1 millimeter, it's a thicker, you know, nozzle. You're gonna have, you know, less detail, but if you're printing a functional part that doesn't need fine detail, you will end up with a stronger part. So, you know, a wider nozzle has that benefit. But when we're dealing with this, a model of a ship, we want a finer print. I'm a little on the fence about using a hardened steel nozzle in place of a brass nozzle because, you know, hardened steel definitely has different, you know, thermal characteristics, but I think it'll be fine. So you have 3 hours, 14 minutes before we can ship it off to the printer. We raised the temperature of the printer bed and, you know, that's evidenced by what Octoprint is showing us here. And I guess if we want to get adventurous, we can tell Octoprint to you know, show up on screen. So I'm actually going to do that. I'm going to go and I'm going to tell my OBS to kindly display the Octoprint window, and we're just going to crop it and resize it. Like, you know, we don't need all of that information right now, so we are just gonna crop. Do we need that? No, we don't really need that. And basically, you know, we are going to, you know, use that just so we have an idea of what temperatures we're dealing with right now. So, oh, that was, see, did you just see what happened there? Oh, wait, that was my camera. Never mind. My camera, look, I have the camera taped right now. Coffee, buddy. I got my turtle walking around on the floor. Now, I'm going to do this. I'm going to move the nozzle a little bit to the right on the x-axis, and I'm moving it up a little bit on the x-axis because I want to be able to access it more easily with my hands, but I also want it to be visible. Now, I purposely grabbed one of the motors because there was like a little gap on the right side here. And I was hoping that maybe I could get that gap to go away by, you know, forcing the motor to pull it down. One of the challenges is keeping both sides on an even keel. So usually I just try to monitor it, make sure they're both, you know, lined up on, you know, the left side and the right side of those threaded rods are like lined up. It's a whole little thing. I mean, like, you got these roller bearings they're like almost like skating wheels on bearings, and they keep it on track. So theoretically, these should be like snug and grabbing onto the rail in such a way that when the left motor moves up, the right side will move up in unison. In practice, if the right side is heavier and something's maladjusted, the right side is going to sag, and that's going to affect your leveling. And so then you have this other issue where as you get to the end of the rod, sometimes you have too much like binding, and so this flexible coupler here helps with that. But I found out if the nozzle slams into the bed, the red and the the separated pieces will separate more, which of course throws off your alignment too. So sometimes what I'll do is as it's coming down, I'll force one of the motors to stop moving. It's not the best way to do that, but it's an option. So real quick, I'm gonna watch it travel in the downward direction and make sure nothing bad happens before I do this nozzle replacement. Oh, whoops. Okay, I didn't mean to do that. I just told it to home. I just told the printer to go home. And so that's what it's going to do. It's going to go home. That is the home position. And then I can move it back up again, which this time, at least I know when I move it 100 steps up, it will go 100 steps up. Whoops, did I click on that twice? Fuck! Pardon my language. I did not mean to hit the home button. I'm like looking at the stupid printer, and I just want to hit up one increment, like one step. That's what I was really trying to do, and the stupid thing wants to go all the way down, and I don't want to cancel it. Anyway, I'm gonna... Yeah, I think the left and... I used the ruler. I think the left and right sides are actually pretty close. And so we can go ahead and proceed with the next step. Because, like I said, I didn't want to mess with it and find out something is way off. So we know it's not way off. So we go 100 steps up. And one of the other reasons why it's good to, like, hit the home button once in a while, even though I was trying to avoid that, is because once you know where the home position is, once the machine knows where the home position is, that's really what matters. It's not going to, like, overshoot the mark, because if the motor thinks it's at 0 right now and it's in the middle, it will keep going past its upper limit. So it's important that, it knows where it is. And of course, at the beginning of a new print, it does do that. All right. So yeah, I gotta print out a camera mount for the camera to be attached to this here. But in the meantime, also I need to print out a lens or a, attachment for a lens so that I can, manually focus it, because a fixed focus webcam obviously is not quite in focus in this setup. And real quick, I'm just gonna scrape away. See, that nozzle here, this nozzle here is basically clogged, but you know what? I don't give a shit because it'll unclog itself once I, put a new nozzle, once I put it back in, it'll unclog itself. For now, we're going to put a new nozzle in while it's hot, and hopefully it won't get loose on its own. One cool thing about these steel nozzles is because they don't conduct heat that well or as efficiently, you can manually hand tighten the nozzle on before you actually, before it actually starts to get hot. Hey, Turtle, where you go? Coffee? Oh, there you are. I do think there is a bit of ooze in the neighborhood there. So I'm going to use a metal pin. I'm going to use this metal pin tool, but I'm going to use the back side of it actually. Now, one really important thing about these 3D printers, and part of my camera angle, one really important thing about this is when you don't touch it for a long enough time, the stepper motor is disengaged. So if I lean on anything right now, like you have the, bed, you can't move it freely like that when the stepper motors are engaged. So the instant I touch any motor and I move it any increment, just one step, now the stepper motor is engaged on all axes. So now I can't physically shove this part around. And this becomes more important anytime you print something big or you have to do a filament change. If you have to change your filament in the middle of a print and it's sitting down for like more than a half hour, then the stepper motors will disengage. And if you start touching anything while that's the case, the instant you move any of the axes, it cannot rehome them while the printer bed is loaded. So, yeah, little thing. So, basically, just moving any stepper motor on any axis will re-engage the steppers. And in my case, I care because I want to be able to put a new nozzle on here without this part sagging on me. So I know now there's at least enough time for me to do that because I just moved it a second ago. Now, it should be noted, these nozzles don't have a hexagonal shape on them. They are, flat on two sides only, but I'm fine with that. Just something to be aware of. So from here, what we're going to do is we can get rid of this window right now because we're going to go back to the Octoprint web GUI, and we're going to instruct it to perform leveling. So this is the existing mesh. We're going to build out a new mesh. And basically it's really simple. The probe, the thingamabob. What's this? Whoops, don't need that. In fact, I definitely don't need that. So basically that little red light over there is, it's got little, stick, basically. It's poking, it's probing, it's determining, at each of these points how far away or how close the bed is. And then it creates a sort of a mesh, a map. And now anytime it's printing, it'll know to tell the Z-axis to move up or down a little bit. Because if this is not quite perfectly leveled, or if, let's say, part of it isn't, quite as level as the rest, that will either result in adhesion issues or other issues with the quality of a print. Now, it just occurred to me that, although I generally like to have what we call a, this thing on the bottom, we call it a raft. I do worry that the raft will adhere too strongly. And we can see right here, like as it does one layer at a time, it's going to do the raft. So it's going to do these lines diagonally, and then it's going to do a new set of lines, in opposition. And then it's going to do a third set of lines. And that's just the raft. And once it's done doing the raft, then it's going to start doing these layers. And so we actually don't even start printing the model right away. We don't start printing the model until like the fourth or fifth layer on top of the raft, in this case. At least it looks like it. Sometimes it's really weird how this visualizes. But what's happening is it's printing out what we call support material. I gotta say, it's very weird what I'm looking at here. If what I'm looking at if I'm understanding what I'm looking at right now, which I may not be understanding it, and so I'm wondering if maybe I should, use a different method of build plate adhesion. And unfortunately, I don't think that's a good option. I mean, problem with this model is this model in particular doesn't really have a lot of places. If it doesn't have any means of adhesion, like what's going to happen on the bottom here, like all of these diagonal points here. I mean, basically this one doesn't even touch the bed in its entirety. So, they need, if the raft is, I guess the raft is necessary after all. As much as it pains me to rely on, something that might rip the bottom layers of the model off, I'll just have to be careful when, it's time. So, yeah, anyway, we just built our mesh. How's our temperatures? Okay, good. Our temperatures are still up. You'll notice this flat line when I was removing the nozzle. That's kind of interesting when I was removing it and cleaning. In fact, I think this is happening when I was... yeah, that was while I was cleaning the nozzle and replacing it from what I could figure. Or perhaps this is during cleaning, and this is when I just put on a brand new nozzle. This is the period of time when the new nozzle needed to warm up. That was, in fact, when it was physically handling the nozzle. So that's kind of cool, I guess, I mean... So now, we're going to go back to the mesh visualization, the bed, and it looks like, whoops, it looks a little off compared to before, but I think I'm going to leave it alone because we're really only concerned about the center of the bed anyway. And when you click on this button, the you know, gantry will actually move. At least it's supposed to move. Like, that's interesting. Oh, I had to put it in the move mode. There we go. So if I click on a point on the bed, the nozzle goes there. So if you, let's say, don't know what corner of the bed corresponds to what you're looking at, you can basically click on it and see where it goes. Although I would advise turning off the mode so you can't move the nozzle by accident. The other day, in the middle of a print, I clicked on one of these buttons here. And yeah, that does not... Apparently, this will let you move the nozzle while it's printing, which you don't really want to do. And it'll move it like in a place where it doesn't belong while it's supposed to be in a very specific place. And same here, this terminal really should have like a lock button on it, because you really shouldn't be able to issue commands to the printer mid-print unless you are damn sure you want to do that. But yeah, so we got our temperatures here. We got our mesh leveling, right? So now what? Well, where is that window coming from? Whenever I switch back to the Cura window, I see the, this... Okay, it's gone now. It says discard or keep changes. I don't know why that comes up right there, but maybe it's a glitch in Windows. Anyway, bottom line is when you change the type of, you know, material, or when you change the nozzle in particular, it will always ask you if you want to keep your old settings. And in this case, yeah. I kept the old settings and then I adjusted them a bit. I basically figured that it probably wants to run at a higher temperature. So, like, once I get the thing printed out that will hold the camera on the end of an arm, and especially once I, you know, get the camera to remain in focus with whatever it's aiming at, I'll be able to monitor the print layer by layer, because, you know, that's something you can't do when the camera's, you know, on the top or the bottom or in the wrong side. Oh, but what I do need to do so I forgot to do two things. One, I didn't even like feed any material into the nozzle, so I might be better off stopping the print and like force feeding the nozzle first and then starting the print over again. And in fact, that's what we're going to do. We're going to abort the print. In fact, yeah, I'm going to do that right now. We're going to abort and start the print over again. Now, when you abort, you always got to remember, at least I find I always got to remember, as soon as it lets me re-enter the temperatures, I want the bed temperature to be back to what it's supposed to be, like right away. And I want the nozzle to be hot so that I don't have to, like, you know, heat it up again. So now we brought the temperatures up. You see it shows on the graph when I canceled it, when I'm resuming it. And now when we go back to our camera view, we can turn this back on so you can see the temperature. And I'm just going to go ahead and make some adjustment. Basically, number one thing I'm going to do is manually move the nozzle up a few steps, and I'm going to manually, using the controls on the printer, I'm going to tell it to squirt out some material. I just told it to move the extruder like 20 steps, 15 steps. So basically we're going to see some plastic squirting out of that at some point. And that's, once we see that, great, good. So now we know, because in the beginning of the last print that wasn't quite happening. And so, you know, we basically just primed it. That would be the accurate term, I believe. Now, one thing I just noticed was the adhesive from the last time I printed on here is mostly gone. And that's not really a big problem, but I'm thinking about reapplying the adhesive right now. So even though this will be out of focus for the camera, it'll be easier for me to access the bed if I move it up a bit. Okay, now we'll put a dot. It doesn't actually have to be perfect. It actually doesn't need to be perfect, but what we do want is, I mean, I'm tempted to redo the leveling routine right now, just because, you know, I did manipulate it just now. I did add some adhesive, so the areas in the center might be a little bit higher than they were before. I mean, meanwhile, I could also elevate part of the bed if I want. I don't really want to re-level it, but I'm going to do it anyway, because I just want to go straight to printing now. But you know what? I added some glue to the printer bed, and so yeah, we need to do that. In the meantime, I'm not going to bore us by watching that happen. What I am going to do is find my turtle so we can have her on camera. Puffy buddy? Puffy girl, where you at, honey? Hey baby, where you go? Where'd you go, my buddy? Puffy? This might take me a moment to find my turtle. Puffy, buddy. Puffy. 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 Shoot. Puffy. Hey, Squirtle, how you doing? Coffee? Coffee! Coffee! Whoops. This is the one problem. Whoops. Ugh. This is the one issue with letting a turtle walk around. They're kind of easy to lose. So this time, I mean, yeah, I think it's fine. So we'll start the print, and then I'll go back to looking for Puffy, my turtle. So, you know, pretty straightforward. We go back up here. And we're going to just tell Kira to initiate the print. And this will probably get canceled again, but our goal is to... Wait, I heard my turtle. I heard a noise. Okay, I'll look for my turtle in a second. But anyway, we're going to basically manually... And you're not going to see exactly what I'm doing, but I have a knob over here on the display, underneath the display panel. I'm going to be moving it in increments of like a fraction of a millimeter at a time in order to, you know, basically like until it's I want to get adhesion, but I also don't want the nozzle to be too close. The nozzle might be slightly too close. But we're gonna see. I'm just gonna keep an eye on it and decide if I need to adjust it further. But I don't want it to be too far. I don't want to have adhesion issues. But if I see anything obvious, I will call it out. Wow, I gotta say, finest lines that I've seen. I mean, this is just the raft layer, right? But yeah, I mean, I'm not accustomed to seeing such fine lines. Ultimately, I want to do the finger touch test. That will be, I think the touch, oh, okay, got to be careful not to lose the finger in there. But yeah, I mean, the outer perimeter of this raft is a little bit high because it started printing it, when it was elevated. But as it builds out these layers in the center here, these layers are on the low side compared to the perimeter. The perimeter of that circular shape, whatever you want to call it, that area is, more bumpy, right? You can feel it more because of the distance of the nozzle at the beginning. Same thing with the mush at the left. It does like a little smearing on the left side here. This is the string that was on the left edge. And, I mean, it seems fine. I don't see any bubbles in there. That was my main concern, is bubbling. It does have a little bit of a texture on there, but I think that's because the nozzle was too far. It could be too close, actually. I could definitely feel in the beginning of one of these lines, the area where I was still adjusting the nozzle. Okay, it's doing the second layer fine. Now, it's too close when it does a subsequent layer and the nozzle is scraping away material or melting away material from the previous layer. It doesn't look like it's doing any such thing, so I think this is working. Yeah, so assuming no of the issues... Assuming no of the odd issues, I think this will work out. I think this will do what I want it to do, which is print the model without too much effort of a higher resolution than what I'm typically accustomed to. And so when everything is said and done, it is my hope that I will indeed have the flagship Hyperion, Yang Wen Li's flagship from Legend of the Galactic Heroes. The only issue I foresee is the back area. I think these rectangular pegs already look kind of small, so they're going to be worse on the next model, but there'll be higher resolution too, so maybe that will compensate for any potential issues I encounter. Either way, gentle... I'm going to gently sand it down, glue it together. This is just like a prototype model, and if it looks really good, sure, I'll paint it, but my goal is to do a test with the 0.2mm nozzle. If this works, then I'm going to print a considerably larger model, possibly as large as my printer will let me print. I will print a larger one using the same size nozzle, especially if like I'm wildly successful with the quality of this print and the functionality of the hardware and everything like that. If on the other hand, also actually, well, I should add, I'm not going to print both ends at the same time. On the large print, I'll only do half the ship in the center of the bed because it'll be more consistent, because the center is always more well behaved when it comes to leveling. But also because if there's a power outage, I don't have any means, for recovering from a power outage. And so if I'm 12 hours into an 18-hour print, I'm screwed if there's a power outage. And so I'd rather lose half the ship, or I'd rather, like, if I finish one half of the ship, but the other half fails, okay, fine, I can start over with the second half. But it would suck to have to start over when doing like a 24-hour print. I'd rather start over on a 12-hour print or whatever it is. I don't want, 36 hours is way riskier than 18 hours. I see you. Wait, I don't see you. Oh, there you are, honey. Oh, I'm sorry. Okay, yeah. Okay, good. Let's hit the record button, video recording, because I want to record a video. I want to start doing a segment on probably Tuesdays. I'm going to basically record the footage, and I'm going to call it Turtle Tuesdays or Turtle Time. I was going to do it on Thursday, but instead I did a recording yesterday, and I figure I get time to edit and upload and schedule a premiere and maybe make it a consistent thing. So for today's Turtle Tuesday segment, it's a hodgepodge of footage I recorded between yesterday and today. Right now we have my friend Poffy. This is my first turtle. I adopted her. I knew her for many years. Yeah, I literally used to sit next to her tank at my friend's house and, watch TV while hanging out with this turtle. And I would take pictures of her whenever she was doing something cool. But usually I didn't pick her up and hold her, except when my friend was cleaning the tank and she was walking around the house. Sometimes she'd flip over and I'd help her up. And my friend's like, oh, you don't have to do that. Because apparently if they flip over, they can flip themselves back over. And if anything, I think in retrospect now I know, I sometimes flip them over on purpose to make sure they can flip over, because it's a health check. And so, yeah, that's today's lesson. A way to check if your turtle is healthy is to flip them over and see if they can recover. Don't do it in water. Do it on the floor, on a carpet, on a wooden floor. Don't flip them over in a shallow tank. And in fact, this is why you don't want a shallow tank. Imagine if the water was shallow and the turtle was upside down. They might have a hard time flipping over without drowning. But in a deep tank, if they flip over in a deep tank, they'll almost immediately recover from that. It's not very hard for an aquatic turtle to flip themselves over if they're healthy while underwater. I mean, they do it all the time. You walk into the room while they're basking, and sometimes they get startled, and they'll just jump into the water. These guys are made for swimming, they walk pretty well, too. Like, it's a common misconception. I mean, they are slower moving because they are awkwardly designed, right? No doubt about it. They are awkwardly designed, But underwater, they're pretty aerodynamic. These guys move faster than tortoises, in my opinion. But also, they move fast because when they're on land, they need to be able to run into the water. If a predator comes by, an eagle comes swooping down to pick this girl up, she needs to be able to run so that she could jump back into the lake or the pond. And so, yeah, that's what happens here. But once again, the lesson today is it's dangerous to have a turtle living in a shallow tank, because if they flip over and nobody's there to help them, they can drown. And that's also why sometimes tortoises with drinking bowls are in danger. Sometimes. But the other thing is tortoises, some of them can't flip over. So many tortoises can, flip themselves back over. But yeah, we've seen that video where a tortoise is upside down and its buddy flips it back over. Sometimes it might be like a natural instinct, but other times it might just be the tortoise friend decided to flip the other tortoise over because they were in the middle of bullying. People don't see the video where the tortoises are headbutting. One of them flips over, and then the tortoise that flipped it over decides to hit it again, not to help him out, but because they just wanted to hit the other tortoise again. But getting back, yeah, so in Africa, some tortoise species do flip over and they could die in the heat or die in the desert of exhaustion, even in the southwest of the United States. And so, yeah, not all tortoises can right themselves once upside down, but red-eared sliders can, if they flip upside down, they can get back in the right position on their own. If they can't, you may want to see a vet or a herp, the veterinarian who handles this type of creature. Beyond that, while Puffy has these festive orange ears, which they say they're red, but I think her ears look more orange. In any case, they are very festive, almost like Michelangelo, right? Her sister doesn't have that. Her sister literally has melanin in place of the orange. And so it's like she has dark stripes right where the red or orange stripes normally would be. But in any case, I had her walking around because she was making a lot of noise, sounded like she wanted to get out of the tank. Got lost under my 3D printer, and now I'm going to bring Puffy Buddy back home to a tank. Puffy, thank you for appearing on camera. Say cheese. Here, we're going to take a picture. Photo op. Ah! That hurts. She got long claws. All right. Let's get a close-up for the camera. So we're going to put the microphone like real close like this. I'm going to put the turtle up here. And we're going to do some super scale. We're going to hold the turtle closer. All right, good. Take a screenshot. All right, Puffy Buddy, thank you very much. I got you, honey. Here, go home. Ready? Drop. Oh, I'm sorry. I didn't mean to drop you that hard. In the meantime, before we conclude this stream, let's see what the printer is doing. So, I mean, it's, like I say, this is awful focus, I know. I thought about like moving the camera out of the printer cage or out of the printer enclosure just so that, it's got a wide shot. I'm going to take a ruler and measure this. We're going to measure the focal distance. 0. Yeah, I might have better luck moving the camera to the front of the cage or the tent. I'll give it a shot. I just used part of the Starship Orville to hold the printer camera up. It's not great, but it might work. So I'll show you what I have here. Okay, so I moved the printer. I moved the I moved the wire, the USB cable, so that it hopefully doesn't disrupt. And then the only thing remaining is, is the lighting appropriate? I think it's appropriate at this point. It's not too bright. It's not too bright. Hopefully, it's not too dim. Sometimes when you move the tent around, you'll get, the camera will shift, but I think it's fine. So, I mean, I'll play with it later, but I just wanted to print, and as it gets to the height, we'll see what happens. But I'm not going to leave the stream running because that would be a waste. I may come back later. I may have to record some N64 gameplay in order to stream, in order to do a Super Mario Brothers movie review, because I had a screenshot from the game, but I'm thinking I should maybe get my own footage from the game instead of using someone else's screenshot on the internet. But with that being said, I want to thank you for watching. Please like and subscribe. If you have any questions, comments, or ideas, please leave a comment. And for now,